So the next step is we use the summary command to extract the variance components from our random effect model. Okay. At this point, we're not really going to use this information, although you should be able to look at this and tell me what are the most important factors in this field for field variation. So genotype's important, which is good because that's what we care about, but in terms of environmental variation in the field, there's a lot more in column than there is in row or quadrant. Okay, so I should be thinking about what is it about my field that led to that. The next step then is to extract the random effects from fit 2, right? And we're assigning that to an object, f_1. Okay, and then from f_1 we're extracting only the random effects for genotype, right? You could probably do this in one step, okay? But I've done it in two. Okay, so f yield blup is going to have the best linear unbiased predictors for genotypes, my treatments, where those blups are corrected based on the variation in rows, columns, and quadrants. Okay? And I can go ahead and write that out. Okay? So now I have a file with my blups. So what do we keep and what do we discard? Okay, so I'm going to kind of leap ahead a little bit. What we would do, and I'm not going to do it just because I don't want to be repetitive, but I would do this for each of the 4 environments, and then I would combine them. Okay? And how you combine them is worthy of some discussion. We can do that in a little bit. Okay? But I can now generate a new histogram looking at the yield. Okay? My yield is essentially 0 because it's a blup. It's been normalized. Right? My standard deviation is 0.25. So I have to decide if I'm making selections just on yield, whether I'm going to go at k is equal to 1 or k is equal to 2. Okay? So if all I was doing was conventional breeding and all I cared about was yield, I'm done. Right? I make my selections. I start using those for new crosses. I advance them to further study, further tests. I'm done. Right? Okay? Again, I've given you some code in the script that I'm not going through line by line now that will allow you to compare the averages of our data with the blup. So the first time that we went to the augmented designs, what we would do is this kind of regression analysis looking at the blup, looking at normalized to the nearest check, looking at normalized to the checks in each column or each row, etc. Okay? Sometimes blup didn't give us the best correlation, but it was always near the top, and it was always much easier to calculate than identifying the nearest check, right? Especially because the checks are also kind of placed randomly within the constraints of at least 3 checks per row, column, and quadrant. Okay, and so it's hard to write an algorithm to automate that process, whereas articulating the model and running a random effects model and extracting the blup is highly automated, right? And so from a data processing point of view, it's much easier. All right, so we can correct for spatial variation other ways, normalize to the nearest check. Once we've corrected each environment for spatial variation, we need to combine that data. Now, since the correction has been made, some people will argue that you can just now average it across those environments, right? You can also combine the data again with another blup. And I would tend to do it this second way, but having said that, I am aware of people that have had papers reviewed where they were criticized for essentially conducting double shrinkage, right? So remember, when you estimate a blup, there's a tendency for the data to shrink back towards the mean. Okay, and so if I calculate a blup of a blup, I'm getting even more shrinkage. All right. I would argue that that's a more conservative approach, right? It's not like you're expanding your differences. If anything, you're shrinking them. Okay, so I'm not concerned about double shrinkage. But if a reviewer comes back to me and says, don't do it this way, I probably don't have a choice, right? Okay. So I just want to make sure that you're aware of that as a potential issue. All right. So, you know, what some people would say is, look, if you're going to combine across environments using a blup, then you should consider your treatments to be fixed effects and calculate a blue first. But blue is really doing the same thing as a blup. There's shrinkage, so there's still double shrinkage, and now you're kind of mixing fixed and random effects frameworks, and I'm actually less comfortable than I am with a double blup, right? And this double blup thing gets complicated because when we come back to genomic selection models, we're using markers to estimate yet another blup, right? Okay. All right. So we've covered merging data, simple manipulations of the data, histograms, regression, ANOVA, fixed and random effects, estimation and extraction of blups. How are we going to use these tools to do a better job at breeding?